So, good afternoon, everyone. I'm Daryl. I'm a research fellow at the Department of Experimental Psychology at UCL, and I'm excited to be here today to share our work on validating AI-assisted evaluation of open science practices. This is a collaboration work with 3 colleagues of mine at UCL. We have been exploring whether AI chatbots like ChatGPT and Cloud can help us evaluate how well researchers are implementing open science practices in their publications. Given that we are all here today at the Open Research Conference, I know you appreciate how important transparency practices are, but also how time-consuming it can be to evaluate them at scale. That's exactly the challenge we wanted to tackle with this study. So let's dive right in. So why did we undertake this study? We all know open science practices are very important, including pre-registration, sharing of data, code, and the materials. They enhance transparency, reproducibility, and the trust in scientific research. Yet, despite widespread advocacy, adoption remains frustratingly low. This recent paper by Hardwick and colleagues found that even in 2022, most psychology articles still weren't implementing these basic practices. The challenge is that evaluating adherence to these practices is incredibly resource intensive. Research teams spend enormous effort manually checking hundreds of articles. Previous automated approaches using text mining or machine learning had the limitations as well, as they needed technical skills most researchers simply don't have. Now, recent studies show that the large language models, or LLMs, have great potential. They can screen systematic reviews and assist with peer review, and also analyze complex academic texts effectively. But here's the thing. These studies typically use LLMs through APIs, which still require programming skills. So we basically wondered, what about AI chatbots like ChatGPT and Cloud? They are web-based interfaces powered by the same LLMs, but they are accessible to anyone with internet access, and no coding is required. And could these user-friendly tools bring the power of LLMs to everyone for evaluating open science practices? So let me quickly walk you through our methods. First of all, we randomly selected 100 brain science articles from UCL Faculty of Brain Sciences REF 2021 submissions. These represent high quality publications, at least I hope so, across psychology, psychiatry, and then neuroscience. We chose REF submissions because they've already been vetted for quality, giving us a strong sample to test AI performance on. For evaluation, we used 6 items from the transparency checklist by SO and colleagues. You can see the reference on the slide here. We focus on pre-registration, sample size rationale, sharing of data, code, materials, as well as data availability statements. We selected these items that couldn't be reliably assessed without checking external websites. Since ChatGPT and the Cloud, at least at the time when we conducted the study, has severe limitations there. For human coding, 3 of us evaluated these articles, which with each paper independently coded by 2 people. For AI coding, we submitted all 100 articles to both ChatGPT-4 and Claude 3.5 Sonnet. We used binary scoring, either the criterion was met or not. For AI evaluation, we used 2 approaches. For ChatGPT-4, we created a custom GPT called Open Science Transparency Check. It's publicly available if you want to try it. For Claude 3.5 Sonnet, we use their project features. Both were configured with identical instructions or prompts to ensure consistency. Importantly, we incorporated 2 prompting techniques. First, future prompting. We provided multiple examples of statements that would or wouldn't meet each criterion, helping the AI understand the nuances. Second, chain of thought and prompting skills. We instructed the AI chatbot to explain its reasoning for each judgment, making the evaluation process transparent. The key advantage of these chatbot interfaces is that they maintain very clear conversation history and the context, unlike API calls. This means you can ask follow-up questions and get clarification, perfect for complex evaluation. As you can see in this example output, the AI evaluates each criterion, provides explanations, and calculates a total score. The scoring mirrors what the human coders do, binary scores of 0 or 1 for each item. For analysis, we examined iterator reliability among human code evaluators first, then compare human AI concordance, both at the overall and the item levels. So let's look at our main findings. First, human iterator reliability was really strong. The correlations between our expert coders ranged from 0.71 to perfect agreement at 1.0, showing that humans apply the transparency checklist consistently. This gave us a solid benchmark for evaluating AI performance. After resolving any human disagreements, we compare the consensus scores with AI evaluations. ChatGPT-4 showed a correlation of 0.69 with human ratings, while Claude 3.5 Sonnet achieved 0.62. Both represent a substantial agreement. And we also found that the 2 AI chatbots also correlated with each other quite strongly as well at 0.73. Looking at the distributions of these scores, there's another striking finding. Most articles score 0. And the majority of high-quality brain science publications completely lacked any of the 6 open science practices we evaluated. While sobering, this is consistent with the recent literature and highlights why we need more efficient evaluation methods. Overall, these findings show promising alignment with human expert judgment and AI evaluations of complex scientific content. Now, let's examine how AI performed on each specific transparency criterion. These heat maps visualize agreement between humans and both chatbots across our 6 checklist items. Each row is an article, and the columns are the criteria. Green means complete agreement. Yellow shows moderate agreement, and the red indicates disagreement. You can immediately see 2 distinct patterns here. First, we have what I call the high concordance group. These include open code, open materials, pre-registration, and the sample size. Both AI systems performed pretty well on these items, with divergence rates between just 5 to 9%. Then there's the moderate concordance group, including data availability statement and open data. These items show the highest divergence rates, with the data availability statement reaching 21% disagreement for ChatGPT. What's particularly interesting is the direction of these disagreements. Looking at the table here, for most criteria, including data availability, open materials, prereq, and the sample size, humans were consistently more lenient. When disagreements occurred, humans typically said that the criterion was met, while AI said it wasn't. This suggests that AI systems apply stricter standards, perhaps looking for a very specific wording or phrases or formatting. The exception is open data, where both chatbots, especially Claude, were often more generous than humans, perhaps not fully grasping that available upon request doesn't meet open science standards. All in all, while both chatbots demonstrate similar overall patterns, some nuanced differences emerge. Chatbot or ChatGPT shows a slightly better performance in evaluating code sharing, material sharing, and pre-registration, while Claude appeared marginally more adept at assessing sample size rationales. Both systems, however, face comparable challenges in accurately identifying and data availability statements and assessing public accessibility of shared data. And now let me share 3 specific examples that illustrate how AI evaluates open science practices. First, the open code example. This article stated that custom code would be made available upon request. Both humans and Claude correctly scored this as 0. Code must be publicly available and not just on request. But ChatGPT gave it 0.5, trying to credit partial compliance. This reveals limitation. ChatGPT sometimes ignored explicit binary scoring instructions, which could complicate systematic evaluations. The second example, the data availability statement. This one is pretty interesting. The articles clearly stated that the data, as well as the custom code for data analysis, are available upon reasonable request. Both humans and ChatGPT completely missed this statement. I'm not sure why, but they both missed this statement and scored it 0. But Claude caught it, correctly scoring 1 for the presence of this particular statement, which is a data availability statement. This shows AI can sometimes catch things humans overlook, particularly due to fatigue or attention lapses. The third example is concerned with sample size rationale. The article mentioned they devised a sample size to allow at least 85% power to detect a difference. Humans considered this sufficient justification, scoring it 1, but both AI systems said no. They wanted a more detailed power analysis. This suggests that AI might apply stricter, perhaps more appropriate standards for methodological rigor. All 3 of these examples highlight a key insight. AI tools bring both consistency and the different perspectives to evaluation. They can catch things we miss, apply standards more uniformly, and also need, but they basically also need clear instructions and human oversight for nuanced judgments. So what does this mean for the open research community? Our findings suggest AI chatbots can serve as valuable preliminary screening tools. Universities could use them to assess large collections of faculty publications efficiently. Administrative staff without specialist expertise can also conduct initial screenings, making evaluation more accessible and scalable. For implementation, we could recommend a structured human-AI collaboration. We should always have human verified data availability statements. That's where AI struggles most. And when AI indicates data code or materials are publicly available, we should have a human check that the links actually work and contain appropriate contents. For pre-registration and the sample size rationales, AI assessments are generally reliable. Now, an important caveat. Our sample showed very low adoption of open science practices. While the AI accurately identified their absence, we don't have enough data yet to indicate how well they performed if the adoption rates were higher. Will they maintain this accuracy when most articles do implement transparency practices? That's still an open question. Despite this limitation, these tools can dramatically speed up the initial screening. Think of them as research assistants that never tire, consistently applying the same standards across hundreds of papers. For institutions serious about monitoring open science, AI-assisted evaluation could be a variable first step. So to wrap up, our study shows AI chatbots demonstrate real promise for evaluating open science practices. The stronger correlations with expert assessments suggest these tools can effectively support transparency evaluation at scale. But they are best used as complements to, and not replacements for, human expertise. They excel at the initial screening and the consistent standards, while humans provide crucial judgments for nuanced cases. As we collectively push for greater research transparency, AI-assisted evaluation could help us monitor progress more efficiently across our institutions. Finally, I would like to take a moment to thank my collaborators, Adam Parker, Connie Nobry, and David Chance, who serve as our expert human evaluators. And here's the QR code linking to our preprint with full details. Our custom GPT tool is also publicly available, but I think they are basically still using the old model rather than the newest ones. And all the data and the code are openly shared as well. So thank you. I'm happy to take any question.
Thank you very much, Daryl. It's really fascinating. Does anyone have any questions now that they'd like to ask?
Thank you. Interesting to see an example of AI that isn't horrific in its implications. But your conclusion is that this is complementary to human expertise.
Yeah.
But is the longer term plan to sort of refine the technology so that you can just do it with AI?
Yeah, so the thing is that this study was conducted a while ago, and it still used pretty old models. And to my knowledge, nowadays, the more recent models are much more capable in reasoning. And I haven't tested it yet, but I suspect that their accuracy is much higher compared to previous models. And I'm not quite sure whether it's possible one day that we can simply use AI tools for this kind of evaluation, and we can simply just leave human evaluators out. I'm not sure whether we can be reach that step or that stage. But at least I don't think that's feasible in the foreseeable future, as we all know that there are a lot of different nuances. For example, even say, for example, like, say, because I actually try to replicate a lot of studies before, and I would say that like a lot of data or the code shared by, even shared by authors, there are a lot of problems with the codes they are sharing. And sometimes it's not about whether we could use their code to reproduce the results reported in their articles. It's more like they made much more fundamental errors in their coding. And I don't suppose AI bots, when they are reviewing a manuscript. But I was wondering if it's possible if we could use some sort of open source LLMs or other methods to basically use AI technology to do some pre-screening, especially the time-consuming tasks. For example, say if we want to check whether a paper or the codes shared by the authors they actually can be computationally reproducible. I would assume that you could use AI to give you at least a preliminary evaluation, whether it's to indicate whether the codes whether it's plausible for the codes to produce the same results as reported in the articles. So for example, if the authors reported t-tests in their papers, but there's no code for t-tests in their code or in their shared scripts, then that should be something called by AI system. And you don't need the reviewers to spend time to read through every line to check whether it's possible to get that kind of result. And yeah, and I think it could be a very powerful tool for us to use in this kind of scenario.